Okay, section 4, chapter 4. We're going to use a coordinate in X, Y, Z to calculate trigonometry function value. So basically, if I have a point in X, Y, Z, so okay, I can take another point here. Connect it to the origin. If I call this is X, Y, so basically this distance is X and this one is Y. Or the same thing, X, Y, then this distance is X and the height is Y. How long from here to here? We're gonna call it R. R equal square root of X squared plus Y squared from Pythagorean theorem, because this is right angle here. So X squared plus Y squared equal R squared. Then R is square root. Now, if I call this angle theta, then what is the sine theta? Is the opposite y over x. What is the cosine of theta? Is the adjacent, which is, well, hypotenuse. Opposite over hypotenuse, which is the r. Then the cosine is adjacent over the hypotenuse, which is the r. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is equal opposite over adjacent, which is x. Then you take the flip of these ones, you get the cosecant, secant, and cotangent. Here you go. If you look in here, this is the sine, cosine, tangent, then cotangent, secant, cosecant. So it doesn't matter what's the angle. Always remember the angle starts from x. Example, they said we have a point -3 and x. Find the point on the terminal side of theta and find sine cosine of that angle. So let's plot that point. 4 on x, 1, 2, 3, and 4, and 1, 2, and 3 negative. Oh no, oh, I did it the other way around. It is -3 on x, -3 on x. Then on y, we have 4, 1, 2, 3, and 4. So this is the point here, -3, 4. Now to find we connect to O, to this origin. This is the angle we're talking about, theta. If this distance here, that's a 90-degree angle, and this is the x, and this is the y, always sine is going to be is y. Oh, I need to find r first. Let's find r first. We need the hypotenuse. R equal square root of -3 square plus 4 square. And that equals square root of 9 plus 16, square root of 25. So R is equal 5. Then sine theta equal Y over R. So that's equal how much? Y was 4 over 5. Okay, this is positive. Cosine theta is equal X over R. X is -3 over 5. That's negative. Okay. Well, notice this point. Remember, this is a quadrant 1, and this is a quadrant 2, quadrant 3, and this quadrant 4. So we are at the quadrant 3. Now, tangent of theta is y over x. Y is 4, x is -3. Then flip this number, you get the other ones. This chart is extremely important to understand where you are. If I name this cosine and this is the sine, in quadrant 1, everything is positive, sine, cosine, and tangent. That's quadrant 1, all positive. Because this is your point, and then you have a positive x, positive y. So everything can come up positive. Now, if I go to quadrant 2, we're going to find out that the sine is positive. However, you can see this point opposite. This is -x, positive y. So because this is -x, then the cosine is negative, the tangent is negative. Remember, always tangent is equal sine over cosine. So this way you can figure it out easy. So if I have sine positive, cosine negative, plus over negative is negative. Now, if I go to the quadrant 3, I have -x, -y. That means my sine and cosine, they're going to be negative. When I divide sine over cosine, the tangent is positive. You go to quadrant 4, you have -y, positive x. That means the cosine is positive and the sine is negative, but the ratio is also negative. So that's the way you understand your cosine and sine relative to the quadrant. Quadrant 1, quadrant 2. So you need to kind of memorize these things to know what's going on. So again, this, if you say this is cosine and this is sine, you know this is positive, positive. Then here you have negative and positive. So, okay. And at the bottom is negative. Okay. Before I do that, let's solve an example. If we have sine of theta equal 5/8 positive. And let's say well, I need to figure out well, let's say sine is negative. Sine is the negative value. And cosine is positive. Find cosine and sine and tangents. What quadrant? To do this, I'm going to draw right angle triangle. Remember, it's kind of like this is the opposite, this is the hypotenuse. So if I draw something like this is 5, and this is 8, and this is theta. And I can leave this negative for it shouldn't hurt. So in order, oh, well, this is 8. This is 8. I don't know this one. So let's call this one A, question mark. So in order to find cosine and tangent, I need to know what is A. A really is equal square root of 5 square plus 8 square. That's equal 25 plus 64. That's equal square root of 9. 6 plus 2 is 8, 89. So what's the answer for this one? Let me get a calculator. $89 square root of 89. That's 9.43. Then cosine is equal the adjacent 9.43 equal over the 8. So that's a cosine theta. And we said they told us positive, so this is positive. Then the tangent, that's pretty easy. It's, you're taking opposite, that's -5/8. -5/9. 0.43. So what quadrant is that? We have sine is negative, cosine is positive, tangent is negative. Well, the easiest way to know, I know this is cosine, I know this is sine, positive, positive. If I go here, this is positive, negative, then negative, negative, then negative, positive. So we're looking for negative, positive. The negative sign, that is a negative sign, and positive guy. So we are in a quadrant 4. Because I have negative sign, positive cosine, quadrant 4. Okay. So we can solve a find trigonometry function based on, we can something similar to this data. Okay. Reference angle. Remember we learned about the coterminal angle before? Coterminal, that every angle they start from one location on X, they end up at that terminal. Now we have a new definition called a reference angle. Reference angle is always less than 90 degrees. Oh, okay. Reference angle always less than 90 degrees. Has to be less than 90 degrees. How do we figure it out? If this is theta, then this is the other, if we say 180, so theta prime equal pi minus theta. That is the reference angle. Okay, reference angle is theta prime, or 180 minus theta. Now, if theta this big here like that, going all the way to quadrant 3, then what is the reference angle? The smaller angle, the less 90 degrees. This is your theta prime. How do I calculate it? It's 180 basically, because this is more than 180, then theta prime is equal theta minus pi in radian, or theta minus 180 in degree. Okay. Very similar to the previous one, but there we are, it depends who's bigger. In a quadrant 4, your theta go really big. Then we have 2 pi is a full circle. So what is the reference angle theta prime here? Theta prime is equal 2 pi minus theta. So you get the smaller angle. Or theta prime is equal 360 minus theta. So reference angle is always less than 90 degrees. You need to, that's the way, we have 3 cases. What happened in quadrant 1? If it's a quadrant 1, theta itself, it is the reference angle. That's the reason that we don't have a drawing for the quadrant 1. Example, find a reference angle for these ones. So this is degree and this is radian. So basically all what you have to do is draw. So this is 0, this is 180, this is 270, this is 90. So where is the 300 should be? Oh, it seems like in the quadrant 4. because it should be more than that's 300 degree. Quadrant 4. That's the first thing we know. So where is the reference angle? Theta prime. Here is the theta prime. So theta prime is equal 360 minus 300 equals 60 degree. That's the reference angle. Let's do last one first, the number C. They said the same angle in here. This is 270. This is 0, 90, and 180. This is negative 135. 135 more than 9, so I'm going backward. And it is less than 180. So the angle is here. So this is negative 135 degree. Where is the theta prime? Here is the theta prime. So what is the theta prime equal? The reference angle equal 180 minus 135. Okay, 5. $45 degree. That's the reference angle. To work a radian a little bit same way, but a little bit harder to do. Unless I need a space. Okay. Let me erase this one. Let's draw the circle. Now, instead of using degree, I'm going to use radian. If this is 0, this is pi over 2. And this is pi here. Pi really is equal 314. Pi over 2, 1.57. Here's 2 pi equals 628. This one, 3 pi. I think it's 3 pi over 4. Yeah, 3 pi over 4 over 2. 3 pi over 2. And 1.5, this is something about 4 something. We could calculate it. Okay. This is 4.7. Okay, 4.7. Now 2.3 where? So if this is 0, 1.7, this is 314. So basically my angle is here. So this angle, 2.3, that's radian. This is a quadrant 2. So what is the reference angle? Here is the theta prime. Theta prime, what's theta prime equal here? is going to be pi minus 2.3, which is 3.10 minus 2.3. If you do that, 3.14 minus 2.3, that's equal to 0.84. So this way you find, it is not too hard to find this reference angle. We already did that. We'll go to section 5. We're going to plot the sine and cosine. These called periodic function, that means they repeat themselves forever. Okay? So if I have sine plot, the question is a plot sine of x. Let's call it x instead of theta. For full cycle, 2 pi. We're going to make a table x and sine of x. We'll start from 0. Remember, we said the circle, you have 0, pi over 2, pi, and 3 pi over 2. And this is 2 pi when we go back here. So we're going to do those major ones. So 0, then pi over 2, then pi, then 3 pi over 2, then 2 pi. And let's see what we get. If I sine, if you use you can use your calculator. Sine of 0 is 0. Sine of pi over 2 is positive 1. So sine of pi is going to go back down, is 0. If you look at the circle, you can find all of these answers in the circle. Sine of 3 pi over 2 is negative 1 because it's the bottom. This is also 0. And you can see the numbers, either 0, +1, or -1. All right, this is X, and this is sine of X. Y equals sine of X. And this is 0. Let's put our point here. Pi over 2, pi, 3 pi over 2, 2 pi. If we assume here this +1 and this -1, but I can do that, and I always like to do that. You can draw kind of like horizontal line. This kind of like the upper limit. You don't have to do that. However, the first point was, let's see this color. The first point was 0, 0. So that's the first point. Second point was pi over 2 and +1. Then we went back to 0. Then down -1. Then back to 0. So this here, from here to here, is a full cycle, or full revolution, one revolution, or one revolution. How do I connect? It's like everything else. If we have to, because this is a function, the connection must be smooth. I go up, make a round corner, go down, down, make another round corner, go back up. That's it. This is one cycle. Now, because this can go for, if I wanted 2 cycles, 3 cycles, 4 cycles, I can continue. I can continue forever. But this is one cycle. I can copy it over and over and over again. Let's see, here is the same thing I just did. +1, -1, pi over 2, pi, 3 pi over 2, 2 pi, and this thing can go forever. It depends how many cycles you want to show. In general, sometimes 1 or 2 is enough. The cosine function. Let me start from 0. The same thing. Plot cosine x. I have to make a table. Similar table. X cosine of x. 0, same x, pi over 2, pi, 3 pi over 2, and 2 pi. 0, the cosine, if we look at it, is 1, +1. Then this one is 0, -1, 0, +1. Kind of opposite of the sign. If I plot this one, this is cosine x, this is x, and then you're gonna put those points, pi over 2, pi 3 pi over 2, 2 pi. And let's assume this is positive 1 and this is negative 1. First point was 0, 1. So that's my first point here. Then the next point up is 0. Pi over 2, 0. Third one is negative 1. Then back to 0, back to positive 1. Okay, if I have to connect, it's gonna, this is from outside, curve, curve, curve. This is one cycle. If I want to show more, I go down, go back up. At the end, later on, it's going to look like the sine, but they are shifted from each other. One start at 0, 0, one start at 0, 1. Basically, if I have to plot the sine here, let's do that. On top of the cosine, okay. Remember, I started at 0. Started from here. Go up, then went down. Went this way. So this is the sine of x for one cycle. They're extremely similar. So all these on x, the point on x, this is called x-intercept. We know this one, x-intercept. That when y equals 0. So this is the x-intercept. Okay. Now this here is the max. This is the minimum. This is the max. This is the minimum. And this is the max for that sine or cosine. So from here to here, that was a quadrant 1. From here to here is quadrant 2. Quadrant 3. Then quadrant 4. Same thing for the other ones. They say the plot, this is another example. Y equal 2 sine of x in this interval. Negative pi to 4 pi. We need to make also a table. That's the best way. X 2 sine of x. They said start from negative pi. Negative pi. What is the sign of pi? It is 0. If I go to the next one, going back, that's negative pi over 2. That should be, if we use your calculator, that's negative 1. Then you are 0, 0, pi over 2. That's positive 1. Basically, the minute you know two of these, if I know 0 and I know negative 1, I know the next one gonna be 0, then positive, then 0, then negative, then 0, then positive. They alternate that way. So if you calculate only two of these, then you know the rest by inspection. So this one here, what is this angle? The next one is pi. However, it seems like this is 2 cycles. The next after the pi is 3 pi over 2. Then we have 2 pi. Okay, let's try to plot. First of all, I made a mistake. Let me correct. This is sine of x, not 2 sine of x. If I wanted 2 sine of x, I have to multiply by 2. 0, negative 2, 0, positive 2, 0, negative 2, 0, positive 2. Let's plot. This is x. This is 2. This is y equal 2 sine of x. And if this is basically positive 2, this is negative 2. Oh, let me put this in the middle or somewhere in here, the 0. So this is y equal 2 sine of x. We put here positive 2, negative 2. This line, the main reason I did remove it because I have a negative pi. So if this is negative pi, then this one negative pi over 2. Make it a little bit smaller. Seems like I'm making it too big. Let's call this one negative pi, half of it negative pi over 2. If this is 0, then this is pi over 2. Then we get pi. Then we get 3 pi over 2. Then 2 pi. Let's stop here. Let's see what we get. First point, negative pi and 0. This is my first one. Let me use different color. This is the first point. Then we have negative pi over 2, negative 2. So this is, oh, this canceled. This is the first point. Negative pi, negative 2, this is the second point. Then 0, 0, that's the third point. Then pi over 2, positive 2. That's another point here. Then we go to pi and 0. then -2, and 0. So let's connect. Well, anyway, let's assume I don't have enough room. So I need another 2 pi. So let's assume this is here your 4 pi. So you're gonna go back up, down, and up. That's the full drawing. How many cycles is that? We have 1 to here, 2.5 cycle. And you can see what they did. They draw for us. The dark color is the 2 sine of x. The shaded gray is just 1 sine of x. And that's exactly what we got. We went up and down, up and down. We finished from -pi to 4 pi. Well, this is easy if just a pure sine x, a pure cosine x. It requires more work if it's more complicated. If you have y equal d plus a sine bx minus c, or same thing cosine. So this is very similar, but 1 time sine, 1 time cosine. How do we plot function like that? That's what we have to learn. So let's see what all these symbols mean. D is shifting up and down. It's like before, shift up or down. C is shifting left or right. Shift left or right. A is called amplitude. That means how high. It's like when we have 2, when we multiply, say 2x, 2 is amplitude. We normally look at it in the absolute value. Absolute A is the amplitude. Well, in this example, I mean, still, we're going to plot something more complicated. In this example, the amplitude is negative. So amplitude A is equal 3. So we know it's going to go this way 3, and this way -3. Okay. need to plot something else. Okay, that's what I'm looking for to plot. It's a process. You have to follow step by step what I'm going to say. First, we have absolute A, the amplitude equal absolute -3 equals 3. This is amplitude. Then in the formula, what was the formula? A cosine bx minus c. Okay, now we're going to define the period equal b over 2 pi. That's the period. What does that mean? Or cycle, full cycle. That's going to be repeated. For this problem, we have 2 pi over 2 pi equal 1 radian. So it happened to be the full cycle here is 1 radian. I'm going to define something called increment. That's equal period divided by 4, because we need to get 4 quadrants like before. And that's equal to 1 divided by 4. And you can use decimal if you wanted to. So quarters, that's my increment. Let's make our table. Let me see. Yeah, I forgot. Let's see. Okay. Okay, before we do the table, we define the period is equal 1 radian. We define the increment as quarter. Well, what is the start of the period? Start of period. What we're going to do, we're going to take whatever inside the parentheses here, 2 pi x plus 4. For the basic one, the start was 0, right? We're going to set this one to 0. That will give us the start. So we isolate 2 pi x equal negative 4 pi. Then x equal negative 4 pi over 2 pi. How much is that? Negative 2. So this is my start is negative 2 of radian. End of period I'll do the same thing. Remember, we started with 0, we ended with 2 pi. We're going to do the same thing. Take this between the parentheses, 2 pi x plus 4 pi equal 2 pi. That's going to be the end. So now 2 pi x equal negative 4 pi plus 2 pi. That's equal negative 2 pi. How much is x? Well, it's going to be negative 1. So we're going to start from negative 2 and end up with negative 1. Now I know the start, I know the end, and I know the increment from quadrant to quadrant. Now I'm ready to do a plot or make the table first. Okay, let's do the table. This is the x. What was the function equal to? Y equal negative 3 cosine 2 pi x plus 4 pi. So we'll put here y, okay? We said the start was negative 2. So what is the next point? We said the increment is quarter to give me from one quadrant to the other one. So I'm going to say negative 2 plus, raise my hand up a bit. Negative 2 plus quarter, that will give me negative 175. Then negative 175 plus the increment equal negative 1.5. Then negative 1.5 plus quarter gonna give me what? Negative 1/4. Now negative 1/4 plus quarter, that will be negative 1. Remember, that was the end. So the start, end. Now we need to figure out the y value. You can go back and plug in here the first number, negative 2. So if I put negative 2 in here, I'm going to get negative 4 pi. So let's do it in here. X equal negative 2. Then y equal negative 3 cosine 2 pi -2 plus 4 pi. That is going to give you -3 cosine 2 and 2, that's 0, cosine of 0. What the cosine of 0 equal to? Equal 1. So the answer is -3. So my first point was -3. Now, if I try the -175, y equal -3 cosine 2 pi multiplied by -1.75 plus 4 pi equal what? This is going to be 3.5. It's going to be -3 cosine half pi. Is it positive? So you have -3.5. So you're going to have half pi. Or pi over 2, basically. What is the cosine of pi over 2? 0. This equal to 0. So we got 0 here. Honestly, right now, as I told you, the next answer is going to be +3, then 0, then -3. Always going to alternate with 0. One time positive, one time negative numbers. Because we start here with negative number, then that must be positive. Then go back to negative. I got all the number down. I'm ready to plot. This is the y value. If we assume this is +3, this is -3. Now, if this is -2, and this is -1, and if we divide this, make 4 quadrants, 4, that's -175, -1.5, -1/4. Now, what was my first point? -2 on x, -3 on y. So that's my first point. -3, -2. Next one was -175, 0. Then -1.5, +1. Or +3, I mean, +3. Then go back down to 0, then to -3. Well, that's all what we need. Connect. Small tiny curve at the beginning. Curve on top. That's it. That's the plot for that function. You can see that's the drawing in the book. We started at -2 as we did, and we stopped at -1. They plotted, then they said we can continue forever if we needed some more. Let's review how. To do the graph, first of all, the amplitude is +3. Then the period is B, which is the value in front of the X, divided by 2 pi. That will give you the period. The start of the period, we take everything in here, set it to 0, then find X start. To find the end, we take everything in here, set it equal to 2 pi, then find the X value for the end. Now, when I make my table, I'm gonna start with -2, because that's the number I find. Then I add the increment to it, which is a period divided by 4. Okay, so the period divided by 4 will give me so the minute I know the start, -2, then I add a quarter, then add a quarter, then add a quarter, until I get to the end. That's what we did. We added a quarter, we got this number. We added a quarter, we got this number. We added a quarter, we got this number. Keep adding quarters until we finished the range. We start at -2, end up at -1. Then we can plug back in here. The minute you know first 2, or then you can figure out the rest. I got -3, then 0, then I know this is +3, this is 0, this is -3. Really, it's very, you don't have to evaluate all of them. Couple should be enough. Trying to find an example. Another example. Let me create one like just. Y equal 2 sine okay, what number? Okay, X two X over pi minus try to make something that will work. Let me figure it out in a minute. You'll make something valid in here. Let's put 1 for right now. So absolute A is equal to. Then what is the period? b over 2 pi. How much is b? b is equal 2 over pi. So let's see. 2 over pi divided by 2 pi. Didn't look like I expected. It's gonna be more complicated. Let's make it 2x only. Then b is 2. So what's going to happen here? You're going to get 2 over 2 pi. So the period is 1 over pi. That's the period. Now increment equal 1 over pi divided by 4. That's equal 1 over 4 pi. That's the increment. The start is 2x minus 1 equals 0. Then 2x equal 1, then x equal half. So that's the start. Now the end equal 2x minus 1 equal 2 pi. Then 2x equal 1 plus 2 pi. Which is 1 plus 2 pi. Then x is equal half plus pi. So that's the end value. Okay. If we have, so we have the start. When I have to make my table, I'm going to say half. That's the first value. Next one, it is half plus, you can convert all to a decimal, 1 over 4 pi. That's the second value. The third value is going to be half plus 2 times of the increment, 2 over 4 pi. Then the next one is half plus 3 over 4 pi. The last one is going to be half plus 4 over 4 pi. Then you can do the table based on that. Yeah, you can well, I'm trying to want to do it in the same page. Let's try to do that. Okay, well, if I plug half, let's say this is my table. This is X and this is Y. If I plug half in here, this becomes 1 minus 1, 0. What is the sign of 0 equal to? 0, right? So 0 times 2, so this is the first number is here is 0. Now, if I add this to it, put X, so sine, let me do it on the side. Sine of 2 multiplied by half plus 1 over 4 pi. Minus 1. Yeah, we can do the calculators. You're going to get 1 plus 1 over 2 pi minus 1. So minus 1 cancel out. We have 1 over 2 pi. And if you do your calculators, hopefully, I think it's going to be this here is going to be positive 2. Then you're going to get 0, negative 2, and 0. Then we can plot it. But you need to do the calculators to convert this to decimal. It would be much easier. But remember, all angle is in radian here. I'm using pi, all angle in radian. So make sure the default in your calculator set to radian. Otherwise, it will not work. So let's give you a practice example to be submitted by tomorrow. We have those two examples. I'm giving you tangent of an angle, 3 over 2, and the sine of A is negative. Use the triangular method to find the 6 trigonometry. And what is the quadrant? You need to figure out the quadrant. And how do you figure out the quadrant? Based on the negative of the sine and positive of the tangent. If you're in the lecture, show exactly how to figure out what the quadrant you are in. It's not that soon. What quadrant? Then we're gonna do the plotting. We have this example. Let me get bigger a little bit. We have y equal negative 2 sine 4x plus 4 pi. Use the step we use in the lectures. You find the amplitude, then you find the period, then you find the increment, then you find the starting of the period, finding the end of the period, make your table, then plot. The 30 point. Due tomorrow by midnight. Okay, that's the end of the lecture.